So in today's class, let us get started with real analysis. In real analysis, the first unit is sequences. So first, let us see what do you mean by a sequence. So a sequence is a list of elements with particular order and repetitions. And the elements in a sequence can be finite or can be infinite. And they determine the length of the sequence. And in a sequence, the element can appear any number of times at different positions. So they find applications in a number of mathematical disciplines like studying functions, spaces, and mathematical structures using convergence properties of sequences. So sequences are the basis for the series, which are important in differential equations and analysis. So first let us see how do we define a sequence. So let us write the definition of sequence. A sequence is a function with domain of a set of natural numbers of the form n belongs to z such that n is greater than or equal to m. So this colon is read as such that. And this is the symbol which we read as belongs to. So we say n belongs to z such that n greater than or equal to m, where m is usually chosen as 1 or 0 with ranges in R. So a sequence is denoted by Sn, where n is equal to m to infinity. These are the limits. N is equal to m to infinity. And Sn belongs to R or Sm, Sm plus 1, Sm plus 2, so on. So if m is equal to 2, then the sequence is denoted by Sn, n belongs to n. So this is the definition and the representation of a sequence. Now let us see what do you mean by convergence of a sequence. So let us write the definition. A sequence Sn of real numbers. A sequence Sn of real numbers is said to converge to the real number S, provided that for each epsilon greater than 0, there exists a number capital N such that small n is greater than capital N implies mod Sn minus S is less than epsilon. So what do you mean by convergence? When can you say that a sequence is converging to some number S, provided for each epsilon greater than 0, there exists a number capital N such that small n is greater than capital N, which implies mod Sn minus S is less than epsilon. So if the sequence Sn converges to S, then we can say limit n tends to infinity, Sn is equal to S, or Sn tends to S. Then S is called limit of the sequence. So this is the definition of convergence of a sequence. So let us take a question. Discuss convergence of the sequence. Sn is equal to n square plus 3 by n square minus 3. So first let us say given sequences Bn is equal to n square plus 3 by n square minus 3. Let us apply limit on both sides. Limit n tends to infinity Bn is equal to limit n tends to infinity n square plus 3 by n square minus 3. So that is limit n tends to infinity. From both numerator and denominator, let us take n square common. So if we take n square common, we get 1 plus 3 by n square. By denominator also, if I take n square common, we get 1 minus 3 by n square. N square get cancelled. So you are left over with limit n tends to infinity 1 plus 3 by n square by 1 minus 3 by n square. So as n tends to infinity, 1 by n and 1 by n square tends to 0. So that is 1 plus 0 by 1 minus 0, which is equal to 1. Therefore, the sequence converges. So when the limit you are getting it as some value, then the sequence converges and its limit is 1. Now take the next question. Find limit of Sn is equal to root over n square plus 1 minus 1. So first let us write down what is given to us. Given Sn is equal to root over n square plus 1 minus n. Now what we are doing is multiplying and dividing by root over n square plus 1 plus n. So that is root over n square plus 1 minus n into root over n square plus 1 plus n by root over n square plus 1 plus n. So now a minus b into a plus b, we get a square minus b square. So it will be n square plus 1 minus n square by root over n square plus 1 plus n. N square minus n square get cancelled. So you will get 1 by root over n square plus 1 plus n. Now in the denominator, if we take n common, so we will get root over n we are taking common, which means within square root we are taking n square common. So 1 plus 1 by n square plus 1. So therefore, limit n tends to infinity, Sn is equal to 0. Because as n tends to infinity, 1 by infinity tends to 0. So directly you will get a 0. Now take the next question. Give formal proof to show that limit 3n plus 1 by 7n minus 4 is equal to 3 by 7. So whenever they ask you to give normal proof or formal proof, you need to do this in two parts. One is discussion, then the other is formal proof. So let's see how to begin. So first let us write what is given to us. Given that limit 3n plus 1 by 7n minus 4 is equal to 3 by 7. First, we will write the discussion part. So what is discussion? Here, we take the sequence as 3n plus 1 by 7n minus 4, where L is equal to 3 by 7, which belongs to R. Now, from the definition of limit, what can you say from the definition of limit of a sequence? For each epsilon greater than 0, that there exists a natural number k such that mod Sn minus L is less than epsilon for all n greater than or equal to n. So this is the definition of limit. Now we take mod. What is Sn? Sn is 3n plus 1 by 7n minus 4 minus what is L? 3 by 7 less than epsilon. Now we will take the LCM here. So cross multiply 7 into 3n minus 3n plus 1 minus 3 into 7n minus 4 by 7 into 7n minus 4 less than epsilon. So this is 21n plus 7 minus 21n plus 12 by 7 into 7n minus 4 less than epsilon. 21n minus 21n get cancelled. So now what is left over? 7 plus 12 is 19. So that is mod 19 by 7 into 7n minus 4 less than epsilon. So what I will do is I will bring epsilon here and I will take 7n minus 4 that side. So we will get 19 by 7 epsilon less than 7n minus 4. Why? Since 7n minus 4 is positive. Now we take this minus 4 this side. So 19 by 7 epsilon plus 4. Then I am bringing this 7 to this side. It will become 1 by 7 is less than n. So what is capital N? That is 19 by 7 epsilon plus 4 into 1 by 7. This is capital N. Now we have to start the formal proof. So let's see how to start the formal proof. So let epsilon greater than 0 and n is equal to 19 by 49 epsilon plus 4 by 7. 4 by 7 n, where n is greater than n. So n greater than, this is n value, right? So 19 by 7 epsilon plus 4 into 1 by 7. So n greater than, if we multiply this into this, 19 by 49 epsilon plus 4 by 7. Now take 4 by 7 to the left hand side. N minus 4 by 7 greater than 19 by 49 epsilon. So if you take LCM, we will get 7n minus 4 by 7 greater than 19 by 49 epsilon. Now let us take the reciprocal. We will get 7 by 7n minus 4. Now if we are taking the reciprocal, inequality will change. So greater than will become less than 49 epsilon by 19. Now we will cross multiply. So we will get 19 into 7 by 49 into 7n minus 4 less than epsilon. Now 7 ones are 7 sevens are. So 19 by 7 into 7n minus 4 less than epsilon. So this is nothing but Sn minus L. that is Sn is 3n plus 1 by 7n minus 4 minus 3 by 7. This is less than epsilon. Therefore, limit n tends to infinity, 3n plus 1 by 7n minus 4 is equal to 3 by 7. Now take the next question. Give formal proof to show that limit 4n cube plus 3n by n cube minus 6 is equal to 4. So first let us write what is the given limit. So given limit is limit 4n cube plus 3n by n cube minus 6. Now first we will start the discussion. So here we take the sequence Sn as 4n cube plus 3n by n cube minus 6, and here limit L is equal to 4, which is a real number. So we write belongs to real number. Now again we write the definition of limit. So what is the definition of limit? From the definition of limit of a sequence, for each epsilon greater than 0, there exists a natural number k such that mod Sn minus L is less than epsilon for all n greater than n. N greater than n. Now let us consider mod Sn minus L, that is mod 4n cube plus 3n by n cube minus 6 minus 4. Now if you take the LCM, 4n cube plus 3n minus 4n cube plus 24 by n cube minus 6. 4n cube minus 4n cube cancel. That is 3n plus 24 by n cube minus 6. Now for n greater than 1, since 3n plus 24 is greater than or equal to 27n and n cube minus 6 is greater than or equal to n cube by 2. So that is equal to mod 27n by n cube by 2. So that is this 2 goes up, 1n get cancelled, you get 54 by n square. Now from the definition, how can we write? We can write 54 by n square is less than epsilon. So 54 by epsilon is less than n square. So if we take n on right hand side, we need to take square root here. 54 by epsilon less than n. So you can say capital N is equal to root over 54 by epsilon for n is greater than 2. So let us start formal proof. Let epsilon greater than 0 and n is equal to maximum of 2 and root over 54 by epsilon. So for n greater than n is greater, for small n greater than capital N is greater than root over 54 by epsilon. So 54 by epsilon, we can write n square greater than 54 by epsilon, or 54 by n square is less than epsilon. So here we can write 27n by n cube by 2 less than epsilon. Now since n greater than 2, n cube by 2 less than or equal to n cube minus 6 and 27n greater than or equal to 3n plus 24. Thus, n is greater than n. So 3n plus 24 by n cube minus 6 less than or equal to 27n by 1 by 2 n cube, that is 54 by n square, which is less than epsilon. So we can write mod Sn minus L. What is Sn? 4n cube plus 3n by n cube minus 6 minus L is 4 less than epsilon. So therefore we can say that limit 4n cube plus 3n by n cube minus 6 is equal to 4.